Uh, Very good morning to all. Today, I would like to take the topic on the reheating. Last time we have discussed for the intercooling as well as there is some related problems. Today, let us. I want to take the next second improving method that is a reheating method. Here, for your syllabus, we have mentioned that is a perfect reheating only. That is reheating, okay, is one of the method to heat that particular amount of exhaust gas again for the highest temperature. That is adding heat. Reheat means adding the heat here. Let us see flow diagram, and here from one air is fresh air will be entered at atmospheric conditions, that will be get compressed, and then point two compressed air that will be sent to the what combustion chamber. That's air will be get heated. Then we it is passed to the what first one is as a high pressure turbine. Okay, then in the high pressure turbine there is a amount of there is some 50% of the this what is exhaust gas, okay, get expansion, and after 50% it will be again go for the reheater, that is a cc2 we have taken. This is a reheater. Then after this will be reached to the what here, that is the same temperature what we have attained at point 3, that is a t3 is equal to t5. This is nothing but perfect reheater, and as you have seen in the intercooler same. And again there's a reach the highest temperature that sent to the what here low pressure turbine, and we can get the what expansion. Okay, expansion taking place, you can get the 0.6 here. And as an advantage you are getting, there is a expansion will be taking place in the what here high pressure turbine as well as low pressure turbine. That means you can get the more power, and it will be run the what first 50% of expansion power will be consumed by the compressor, and another this one expansion low pressure turbine expansion that will be help to get more power. That's what by reheating we can get the what here higher efficiency. Okay, and same we can transport to the what here ts diagram as it is what I discussed in the previous intercooler here. See ts diagram, temperature versus entropy. Now at the it will be operating between the what here on low pressure and high pressure. Here you can observe that is a p1 and p3 is a low pressure and p3 is a high pressure here. And you can observe here this is a p5 is equal to p4. This is a intermediate pressure as you have seen in the what intercooler here. At the past of at the first, that is point one. Okay, point one, that will be atmospheric air condition, that will be transferred to the what compressor, and it will be passed to the what here compressor, and temperature, okay, rises, entropy remains same there because of this is a ideal case now discussing. And point two, first combustion chamber will be passed, that's what temperature increases, entropy increases from point 2 to 3 here. Okay, now let us will go for the what here point 3. It will be passed to the what here point first turbine, high pressure turbine. Okay, high pressure turbine, and see this one 3 to 4, there is an expansion from the what 50% expansion from the high pressure turbine, and 4 to 5 again it will be passed to the reheater or combustion tube, and the temperature increases from 4 to 5. And you can observe that is a it will be reaches up to the what t3 temperature. That's what t3 is equal to t5. Okay, and again you can see this one here 5 is inlet for the low pressure turbine, and 5 to 6 okay, 5 to 6 I think is not written here, please note down. 5 to 6 expansion. Okay, this is an ideal case. Okay, now see 5 to 6, after 5 to 6 expansion, and is a exhaust went to the water atmosphere. We have seen 6 to, okay, 6 to 1 is a this one here 6 to 1 you can note down. That is this is point 6. See this is point see now I'll mention this is point 6 okay, now you can see this one point 6 here. Okay, 0.6, 5 to 6 you can get over here. That is an expansion taking place, and 5 to 6 dash is a actual. Okay, now you just note down this one here. 3 to T3 is equal to T5, and next one is you have a T4 is equal to T6. Okay, now this is will be temperature remains same, that is whatever temperature. Okay, that is again reduced to the what origin. That's what we will be calling as a perfect reheater. T3 is equal to T5, T4 is equal to T6. In the case of actual case, we have that is T4 dash is equal to T6 dash. Okay, now these are the all the temperature equal. Now this is will be calling as what a preheater. See, same we can discuss um, now same we can discuss for the what here, that is actual cases 1 to 2 dash, that will be calling as a 1 to 2 dash will be calling as a actual. Okay, and here two expansion process, that is a 3 to 4 dash and 5 to 6 dash actual case. Okay, sometime we'll be just compare between the what here reheating and with reheating and without reheating. That's what I have taken. This is a 3 to 4. Okay, 3 to 3 to 3 to 8. Okay, if you taken this on expansion directly, okay, in the single turbine, that is as good as what you can call as a, this is a as good as, this is as good as, this is a simple turbine without reheating. Same only you can expand. There is a 3 to 4 and 5 to 6. Okay, 5 to 6 not there here. Please note down here. And this is calling as a reheating. Okay, now without reheating directly, expansion taking place 3 to 8. Okay, this is calling as a without reheating, and in the actual case 3 to 8 dash. Okay, sometime comparison between reheating, okay, and with reheating and without reheating. Sometime you should be write the equation, and based on this concept, let us will be write for the what here, thermal efficiency with reheater and thermal efficiency without reheater. I'll write the expression for the efficiency. Let us one by one. For ideal case, same formula, that is a net work divided by heat supply. Okay, WT minus WC. Okay, now we can see turbine expansion will be taking, see the TS diagram, HS diagram. See TS diagram, turbine work will be happening in the two. Okay, two turbines. One is 3 to 4, another is a 5 to 6. Okay, is a another is a 5 to 6. Okay, now that's what based on this one here, there is a, we can write this as CP T3 minus T4 plus CP T5 minus T6. Okay, there's a addition of two turbine. One is a expansion taking place in the high pressure turbine, and there is a expansion taking place in the what here, low pressure turbine. That's what this total this is a turbine work. Okay, and minus compressor work is only one. Okay, see the TS diagram here, T2 minus T1. Okay, now heat supply. Okay, see the heat supply, where is the heat supply? See, in the ideal case 2 to 3 as well as 4 to 5. Okay, as well as 4 to 5. That's what you should be addition of this work 2 to 3 process and 4 to 5 process. In the ideal case you should be mentioned. That's what the CP T3 minus T2, because higher to lower, always you would take some temperature higher to lower, and plus CP TP minus T5 minus T4. This is a total heat addition. Okay,